Yes, class. So in the last class, Sufyan and Taha, we have completed the electric field portion and torque portion. So just one topic is left, electric flux is left. And let me start with the discussion of that. See, number of electric field lines crossing an area normally is called electric flux. It means suppose if I have a sheet, and from this sheet one flux is passing, one electric field is passing from here, one electric field is passing from one electric field is passing from here. So all these are electric fields. So this is 1, this is 2, this is 3, this is 4. All these are electric fields. So see, if these make an angle of 90 degree here, if these are making an angle of 90 degree over here. So 1, 2, 3, 4. So these number of electric fields which are passing over an area perpendicularly, these are called as the electric flux. So what is electric flux? Number of field lines. So it will be simply 4 over here. Why? Because it is the number of field lines which are crossing an area, and see, it has to be perpendicular. Perpendicular also you can use the term normal to, normal or perpendicular, both are same. So if it does not make an angle of 90 degree, we won't consider it as the part of the electric flux. So for an electric field line to be a part of electric flux, it should have certain conditions. First one is that it should cross through a surface area, the electric field. And second one is that it should be 90 degree, normal, making an angle of 90 degree. Now see, every time, see here we had 4 lines. So I could easily count it 1, 2, 3, 4, right? But if I do not have 4 lines, suppose I have 8 lines, 10 lines, 20 lines, that also I can count. But what if I have such a number of field lines that I cannot calculate, that I cannot count? Many things are present which you cannot count. And obviously in the exam, you'll not sit up with calculating all the electric field which is moving. So the best method here is simply use a formula. Now to understand the formula, you should have the knowledge of the dot product. Now look here, electric field is here E. Now this is basically a perpendicular which is drawn. Perpendicular which is drawn. We call this as area vector. This is called as area vector. It is always 90 degree to the plane. This is always made at 90 degree to the plane surface. Fine. This is our electric field. So there must be an angle between the electric field and this area vector. This is the theta angle. All right. So electric field is at a random angle. Area vector is perpendicular to the plane surface. And theta is the angle between them. Fine. So theta is the angle between them. Now the formula is simply phi is equal to E dot S. You take the dot product. So phi will be equal to magnitude of E, magnitude of S. What is S? S is the surface area. E is the electric field. So electric field into surface area into cos theta. What is the theta? Theta is the angle between the area vector and the electric field, right? So ES cos theta simply you can use. So it's a scalar quantity flux. No need to worry about the vector loss. SI unit is Newton meter square per Coulomb. Write it down till here, then I'll discuss. Okay, let's move further then class if you've done. If you are done, so see, one thing, if the area vector you are writing, fine. And see, from a surface, you have three area vectors drawn, like this. So see, for a particular surface, area vector will be the same. Understood class? Area vector will be the same for any plane surface. Why? Because it will be perpendicular, right? It will be perpendicular. So what will happen? If it is perpendicular, it is the pointing in the same direction. So one is n vector, this is n cap, this is n cap. And all of these three are pointing in the same direction. So whatever surface you take, direction of area vector will be the same. Now curved surfaces when we are talking. If we are talking about the curved surface, there also we will be taking n cap. So n cap will be perpendicular to a small portion of the area vector. All right, like this. Area vector, it will be perpendicular to the small curved surface area. So we take a small element, which is ds. Now here also the same thing. It's just that we take the closed surface, which is in contact. So surface is closed. This symbol, symbol shows that surface closed integral. All right. So these are for all the curved spheres which are possible, all the curved surfaces, spheres, hemispheres, cones, cylinder, and all for every. All right. Write down these notes, 2 note points, then we'll do the numericals. Okay, let's see the numericals class. See, here it says that electric field E, which is 10 Newton per coulomb, exists in space. Calculate flux through an area of 5 meters square in XY plane. If the field lines are inclined at 60 degree with the plane of the area. Now C class, pay attention here. Taha and Sufyan. See, electric field is making 60 degree with the plane. So instead of taking this angle, it is given this. This is given. Electric field with the plane. Look, here it is written 60 degree with the plane of the area. Means this is 60 degree. But do we require this? No, we always need this. This is our theta. So what we'll do? We will subtract, this total is 90 degree. So we'll subtract 60 degree, we'll get 30 degree. So here when we'll put everything, the flux will be 10 into 5 into cos 30 degree. So this is equal to 5 into 10 into root 3 by 2, which is equal to 25 root 3 Newton meter square per coulomb. Write this question quickly. See, now the next question. Here we have electric field given and it is exist. Electric field is given I cap plus 2j cap plus 3k cap, and surface area is also given I cap minus j cap plus k cap. So when we take here the dot product, see coefficient 1 gets multiplied to 1. So it becomes 1 plus, which is the next coefficient of j cap, 2 multiplied to minus 1, right? Plus 3 multiplied to 1. So this is 1 minus 2 plus 3, right? So this is 3 minus 2 is 1. This is 1 Newton meter square per coulomb left. All right. Sorry, 2. 1 plus 1 is 2. So this will be 2 Newton meter square per coulomb. Write it. See class, in the next question, we have the information about the electric field, right? But we have no information about the area. This is just written as 5 meters square. So how will we write the Cartesian form? So best thing is that, see, it is written in XY plane, right? It is written in XY plane. So we draw the area vector perpendicular, right? And the third, first is x-axis, second is y-axis, and third is our z-axis. So that's why we have written it as k cap. Now for flux, you just multiply I cap plus 2j cap plus 3k cap dot this is into 5k cap. So when you multiply, I and 2 have nothing because they have do not have coefficients of I cap, j cap on the other side. So you just multiply it with 15 Newton meter square per coulomb. Fine, this is the answer. Now, one more point before we come to the next question. Whenever we are talking about surface integrals, remember, for the smallest portion that we have chosen, suppose we have chosen this. This is the smallest portion that is possible. Fine. So what we'll do, we will take integral of ds. Integral of ds means whatever is the surface area, we'll consider that. We'll consider the surface area. Fine, we'll be considering the surface. Suppose we here have ds, so we'll be considering the surface area of the entire sphere. Like here, it's just a rectangle which is made, and we just have taken this for our reference, this small portion from the cylinder. But what we'll do, we'll take the entire cylinder's area when we are taking ds. Write it quickly. Okay, class, this is a little important question. It says that charge Q is placed in the center of a sphere. Now we have to calculate the flux through it. See, phi is equal to E dot S. Now ds, I have told you that ds is the entire area of the sphere. So it is 4 pi r square. Fine. ds is 4 pi r square. And what about the electric field? Electric field is kq by r square, right? K is 1 over 4 pi epsilon naught. So let me write down the values. E is q by 4 pi epsilon naught r square and ds is 4 pi r square. So r square, 4 pi got cancelled. Flux is equal to q by epsilon naught. Now pay attention here, class. What exactly is this? This is basically our Gauss law. Gauss law says that the electric flux which is enclosed, it is 1 by epsilon naught times the total charge which is enclosed. All right. This is 1 over epsilon naught times the total charge which is enclosed. This is what is the statement of Gauss law. And see, the derivation is here. This question is actually the derivation of Gauss law. How to get phi is equal to q by epsilon naught. So that's why we say flux is equal to charge enclosed by epsilon naught. This is what is our Gauss law. So according to Gauss law, electric flux through a closed surface is 1 by epsilon naught times the total charge enclosed by the surface. This is the entire process and meaning of the Gauss theorem. Fine. Now there are few properties of Gauss theorem. I'll discuss it. First, you copy down till here. Done. Okay, now let's come to the properties class. So the first property is that it is independent. Flux is independent of the shape and the shape and the size of the surface. Means I have this sphere. The charge here is Q and the radius is R. So my flux is Q by epsilon. But if I double the radius, I make it 2R, still I'll be getting the flux as Q by epsilon naught. Because flux depends upon the charge enclosed. If the charge enclosed is same in both the bodies, having the radius R and have the radius 2R, my flux will be same. Like this is a rod which has charge Q. So flux is Q by epsilon naught. Similarly, here is a random shape and figure. So this is Q by epsilon naught. All right, just a second, class. Okay, so the next point says that, see, since flux is scalar, whenever you have to first add all the charges. Like, look here. Here you have, when we are calculating the total charge enclosed, we have here plus Q1, then minus Q2, plus Q3. That's it, divided by epsilon naught. That's it. This is not divided by epsilon naught. Wait. This is the total charge enclosed. And if I have to calculate the flux, I'll take it as Q1 minus Q2 plus Q3 divided by epsilon. This is the total flux. I will, in all of these charges given, I'll be considering this, I'll be considering this, I'll be considering this, but I won't consider these two because these two are lying outside, right? So we'll be just considering the charges which are enclosed. Now, all the flux which is moving outwards, it is taken as positive. And the flux which is moving inwards, it is taken as negative. Fine. So whatever answer you get, ultimately, finally, you'll make it positive and negative. Then fourth point we have. Fourth point means that if suppose electric field is just crossing, not penetrating, it's just crossing. So see, our area vector will make an angle of 90 degree with the electric field. So if ES cos 90 degrees there, this becomes 0. So flux also becomes 0. So one point is that if electric field is not crossing this proportion which is present, then we'll say electric flux is straight away 0, right? If this portion is not being crossed by electric field, straight away flux is 0. But if you have to show it mathematically, you can show by cos 90 degree. That cos 90 degree is 0. The angle formed here is 90 degree and cos 90 degree here is 0. Last point is of the dipole. Dipole's point is, if you have a dipole, what will be the charge enclosed? Minus Q plus Q. This will always be 0. So flux will be 0. These properties you should remember. Write it. Then 2 questions we will see from here. In this question, we have a charge placed in the center of a cube. Now we have to calculate the flux through the cube. So from the, if you have the entire cube present and a charge is present inside, so total flux will be Q by epsilon naught. Why? According to Gauss law, right? This will be the formula. Now, if we are calculating flux through each phase, the question is through the cube is this, but what is the flux through each phase? So see, what is the flux through the cube? Flux through the cube is Q by epsilon naught. So flux through a cube can be written as 6 faces. A cube has 6 faces. So flux through 6 faces is Q by epsilon naught. So flux through one single face is Q by 6 epsilon naught, right? See, one more question I'll show you. There's a hemisphere present and we have to find out the charge which is placed at the center of the hemisphere. So see, flux through the entire sphere will be Q by epsilon naught. A sphere means two hemispheres, right? So flux through two hemispheres is Q by epsilon naught. So flux through a single hemisphere will be Q by 2 epsilon. Write down these two. Sufyan, you had submitted the homework on electric field lines that I have seen. But after that, only one homework you have submitted, I think. You have submitted one of vectors that was done a long time back, right? There was a question based on vectors when the revision was done. And electric from this chapter, you have submitted two homeworks only. Electric charges and electric field lines. Where are the rest of the homeworks? Taha has submitted electric field, electric charges, electric field lines. Please submit the recent homework class.
Okay.
One more thing I wanted to discuss. I had seen it in Sufyan's assignment. Now let me just share the screen. Sufyan, look here. Whenever you have these questions, now see, rest of the things were good, but these questions, you have cancelled K, and see, rest of it, you couldn't cancel it, right? So you will not put 2 by yourself. In the numericals which we have calculated, which we have submitted, there we have used 2 because in the numerator 4 was given. Okay, Sufyan?
Okay.
You both have not attended the test also. Have you, Sufyan, Taha? Have you attempted the weekly test? Any weekly test?
No.
No. And Sufyan, what about you?
No.
So were you not notified about it?
No. We get a message. I didn't get a message.
Yes, Sufyan?
I didn't get a message about it.
Okay. And what about you, Taha?
No, even I didn't get anything.
Okay. So please attend the tests. Whatever we have completed, that portion only comes in the exam. No, that only you have to attempt. Okay, write it. Let me know once done. I hope you have completed writing. Okay, let's talk about the continuous charge distribution. Now, in continuous charge distribution, we have 3 types, 1D, 2D, and 3D. 1D is about this. We represent the linear charge density through lambda. It is one-dimensional. Means whatever is the charge per unit length, that is called as the linear charge density, like charge per unit length. Fine. So here Q represents charge and L represents the length. So the SI unit is coulomb per meter, and this is if you have variable charge, then you will use this. If you have constant charge, see, if charge is constant, use this. If charge is not constant, that is variable, use this. Like, see, I'll share a question. A charge of 10 coulomb is uniformly distributed on a wire of length 5 meters. You have to calculate the linear charge density. What is the charge? 10. Charge per unit length. This is to coulomb meter. Now, it says charge on 2-meter length of wire. Now see, when you are calculating charge on 2-meter length of wire, first we need what is the charge in 1-meter length of wire. So in 1 meter, we have 2 coulombs. So in 2 meters, straight away, we'll have 4 coulombs. Just apply the unitary method. One more question, I'll discuss it. Write it from here. Yes, class. So we'll continue in the next class now. Just tell me, Sufyan and Taha, on Monday, are you both available? Do you have any class on Monday? Chemistry, maths?
Ma'am, math and chemistry.
Maths and chemistry, same as Wednesday. Okay then. See, on Monday, 5:30, 5:30 IST. 3 p.m. are you available? 3 p.m. KSA timings. Just for 1 hour class.
Yes, ma'am.
Okay, then 3 p.m. Sufyan, for you as well. 3 p.m. to 4 p.m. 1 hour class I'll just take. So that we start with potential portion also and we complete this part at least. Sufyan, it's fine.
Wait.
Okay, this is
check.
KSA timing. It means if it is 3, so it will be 4, 5, 5:30. 5:30 IST. Okay, 5:30 to 6.
Yeah, it's fine.
Okay, then let's meet on Monday. You can leave now. Thank you so much.